In this class, we're going to take a look at how you solve a trigonometric equation. So some trig equations allow you to use a calculator, some are expected to be done manually, some are in degrees, and some are in another way of measuring angles called radians. Now, if you're just starting trig equations, which is probably where these guys belong, like entry level, then it would be assumed that you'd be doing these with a calculator and in degrees. As you get further into trig, you'll start doing some of these manually without a calculator, and you'll start to use radians, which is just another way of measuring the angles. So we're just going to look at the process for solving these, and I'm kind of assuming you're already familiar with things like the inverse of a sine or a cosine or a tan function, so that's the button on the calculator, and using, for example, the cast diagram. So if you're not sure about those things, just follow along, and we develop those in the course anyway. So having a look at this first one, this is pretty much as simple as a trig equation can get. There's no manipulation of algebraic terms. We're always wanting to get our trig equations to the point where we've got the trig function, cosine in this case, on one side and the number on the other. That guy there, we would need to manipulate the algebra a little first, and we'll get to those in a moment. So the other thing with a trig function, a trig equation, that you've always got to have is a range of values. So a typical range of values would be that x has to lie between 0 and 360 degrees. And that's one cycle of the cosine and the sine graph. Tan graph's a little different. But every trig equation has to have this, because without that, you've basically got infinitely many solutions. Because the graphs of these functions keep going on and on and on forever, you would just, if you graph the solution to the equation, you would keep getting more and more solutions on the graph. So you've got to have this range of values. So usually it's 0 to 360. I think for this one here, we're going to do it 0 to 180, just to get a bit of variety. And we'll deal with that one in a moment. So starting off with this one, where there's no algebra to do, so you can go straight to basically using the inverse on the calculator. So that's just using usually the shift cosine button, but it depends on your own particular calculator. So it's going to be cos inverse of 0.7, that's how we write it. So you're literally just processing that into the calculator. That comes out to be 46 degrees, okay? The other thing we need for these is the cast diagram. So if you're not familiar with this, it's going to be a little bit confusing, and I would recommend checking out the class to do with the cast method if this is not familiar to you. But I'm just going to work up this thing called the cast diagram. So the cast diagram goes 0, 90, 180, 270, and then back one full cycle to 360. In the case of this question, we've got cosine equaling a positive value. It's all about whether this is positive or negative. So it means that we're going to check the two positive cosine quadrants. Again, if you've never seen this before, you'll have no idea what I'm talking about. If you've seen it before, you'll understand. If you've not seen it, check out the class on the cast diagram, so we know how to solve this trig equation. So that tells us the solution should be between 0 and 90, which is where that one is. So that's our first solution. That's the one that goes there. The second one we get by making an adjustment from 360 degrees, and we do that by writing just 360 minus the first solution, 46, which is 314 degrees. So now that we've got the two numbers tallied up with a cast diagram, we can kind of validate that they are both our solutions. And remember, you're solving these for x. So x is inside the cosine function. This is the cosine of x. So we can say that our two x solutions are 46 degrees for the first one and 314 degrees for the second one. So that's how we go about a trig equation. It's quite a lot of technique to piece together. It's not easy, takes practice, and they get more difficult, of course, as you go further into them. Let's take a look at the second guy. So it's not quite in the correct format. We need to get the tan on its own like we had with the cosine over here. So if you move the 1 over to the other side, just doing normal algebra, so you get 2 tan x equals 1. Dividing both sides by 2, and you get tan x equals 1 over 2, or you could write that as 0.5 if you prefer to use the decimal. At this point, we might do the cast diagram, so I'm just going to put it over here. You can do these quickly, you don't have to be too elaborate when you do them. So we've got tan equals a positive value, so you're checking the two tan quadrants, which is the T and the A quadrant, and we're just going to then put that in the calculator. So we're going to do tan to the -1 of 0.5, so that process never really changes. 0.5, and that comes out to be 26.6 degrees. Okay, so that is 26.6 is here, the first quadrant between 0 and 90. Now notice that for this question we're restricting our values to 180. This is 180 here, so that says that all of our solutions have to be in the first two quadrants. Even though we've got a check down here in the third quadrant, we're not allowed to go any further than 180 for this question, so we need to take that one out. If that was 360, like it was in the first question, which it often is, then we would be allowed that one. So for this one, we're kind of done at that point. So just checking, first quadrant's where the check is, so that's fine. That means we can assign x to be 26.6 degrees as our solution. If we did change that to 360 degrees, and that would then mean that we're allowed to put that check back in to here, that would mean we would get our second solution by doing 180 plus 26.6. So the second solution in that case, 180 plus the first solution, which gives you 206.6 degrees. And that would be our two solutions for that one. So not easy, just that one's stepping it up a little because we had some more algebra to consider at the start, and for the 180 we had to consider the range of values. So let's take a look at the third one. We're not going to finish this one, we're just going to make a start, and I'm going to highlight what the issue is with this one. So let's say our range of values is 0 to 360, which would be standard kind of range when you're starting these questions. We'll start by manipulating the algebra. So we get 2 sine x equals -1, just moving the 1 to the other side. Dividing both sides by 2, and we get sine x equals -1 over 2, or you could write that as -0.5 if you prefer. So this time it's come out to be a negative number here. So we had a positive here, we had a positive here, this one's a negative. The problem with that is, there's a few problems, or not problems, but just changes to the technique we've got to use to solve it. It makes it more difficult basically. So when we come to draw our cast diagram, which you always really need for a trig equation, either the cast diagram or the graph of the function, the cast diagram is quicker and a little more efficient. So again, if you're not familiar with the cast diagram, then check out the class on that, and then maybe come back into this class. So we've got this time sine equals a negative value. If it was a positive value, we would be checking here and here, because these are the quadrants 1 and 2, where sine is positive, but we've got a negative value, so it has to be the other two quadrants that we're checking. So that's 0, 90, 180, 270, and then 360. So what that tells us is that we're looking for a solution between 180 and 270, and we're looking for a solution between 270 and 360. That's where the two solutions to this trig equation lie. Another way you can visualize that is, if you're familiar with the sine graph, you can draw the graph, which looks something like that. If you mark on -0.5, which is like down here somewhere, so that's -0.5 on the vertical axis, so on the y-axis, and then kind of go along until you hit the graph, which would be like sort of there, and then again like there. These 2 points represent your solutions. So you can see the solution between 180 and 270, that's this guy here. The solution between 270 and 360, that's that guy there. So that's just another way of visualizing information from the cast diagram. The technique for solving this is a little different. We're not going to look at that in this class, but that is explained in full in the course. So if you've already done these entry-level ones and you've gotten comfortable with these, then this would be one of the next things that you would start to figure out. So if you've never done trig equations before, then hopefully this makes sense to you. The cast diagram might not, so you might need to check that out separately. The challenge with these is learning the technique, piecing all the bits together, and just starting to see different variations of the question type. The more variation and the more experience you can get with the different questions, then just the more capacity you'll have to answer a wider variety of question types. So hopefully that makes sense. That's basically how you solve trigonometric equations.